Welcome to Understand the Math. In this question, we're going to determine by inspection, that means we don't have to do any row reduction, whether the vectors are linearly independent or linearly dependent. I often tell my students these are like our special cases. Let's start by looking at problem A. In problem A, what I want you to notice is that we have a vector v2 and it's equal to 0. So let's write that down. So I'm going to write down that v2 is a 0 vector. And whenever we have a set of vectors and one of the vectors is the 0 vector, that set is linearly dependent. So we'll write down linearly dependent. Let's now look at part B. In part B, what we need to notice is that there might be a relation between V1 and V2. So let's go ahead and let's start. Let's look at these numbers. Do you see that if we multiply -2 by -4, we're going to get 8? Let's see if that holds. If we have a 4, multiply it by -4, oh, it does. We get a -16. And then 1 times a -4 is a -4. So we can write down that V1 is -4 times V2. So this means that these vectors are multiples of each other. And whenever you have two vectors that are multiples of each other, the vectors are linearly dependent. Even if you have 3 vectors and 2 of them are multiples of each other, the set will still be linearly dependent. Let's now look at part C. At part C, I want you to notice that we have 3 vectors and each vector has only 2 entries. So I'm going to write this down as more vectors than entries in each vector. Whenever you have a case like this, the vectors are linearly dependent. The reason for this is if you were to put V1, V2, and V3 in a matrix and row reduce it, because of the structure, every column could not have a pivot. So you're always going to have linearly dependent vectors. Let's now look at part D. At part D, we have 2 vectors, and let's see if they are multiples of each other. So if we start with 1 and we multiply it by 2, we get 2. If we take 4, multiply it by 2, we get 8. And then if we take 5 and we multiply it by 2, we would actually get 10, and instead we have a 3. So that tells us that V1 and V2 are not multiples. We can write this algebraically as V1 is not equal to K times V2. So we have 2 vectors, and they are not multiples of each other, so that means our vectors are linearly independent.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.